logarithms itself, we need to ensure that the base is the same. So we check through everything. Okay, all the terms, we notice that they all have the same base A, right? So that means that in order to simplify, we will apply our laws already. Okay, since there are two separate logarithms with the addition, we know that we can apply our product law to say that we have log A 50 times 8 over 25. Okay, that is for the first two logarithms. Then for the third one, okay, before we go into merging it with the first two, we may want to apply our power law to bring the two up to become 10 squared first. Okay, then for our 25, here leave it as it is. 50 times 8 over 25, you can simplify that using your calculator, that will be 16. Okay, 50 times 8 over 25 is 16. Right? Then this one will become log base A 100. Followed by continuing the same process, two logarithms with addition, so we can multiply. Since after that it's a minus sign, so multiply already, then we divide by 25. So you could actually merge that into one step. Okay? So in fact, right at the start, if you want to merge everything into one step, that's fine, just that we need to be extra careful. Okay? So I don't really encourage that, that's why this is the bare minimum I'll have. So we get log base A 64. That's all. Okay? Questions? Next, 13A. Our right hand side, which is 3 log base A total. Okay. So always have the goal in mind. So we notice that the logarithm at the end has a base of A. So we need to work towards that first. So everything in our right hand side has a base of A, so there's no need for us to do any change of base. Okay. So what we will do now, similar to what we have done in 12C, in fact, apply our power law, bring all the numbers in front up first to become 2 squared. Likewise, this becomes 3 cubed. Okay? Then we simplify it part by part. This is a plus, so it becomes 4 times 10. 3 cubed is 27. Okay, notice that I'm not trying to pair things up like that, because it is wrong if you take this but minus away this one, because there's a minus sign over here. So it's supposed to follow your Botman's rule going from left to right. Okay. So this will give us 40. Then we will have 40 divided by 27. Okay. Then because later on you will still minus away the log 5 base A. So minus 2 separate logarithms minus, that means you continue to divide again by another 5. Okay. Alright, so you can go and calculate 40 over 27 divided by 5. That will give us 8 over 27. It is very helpful if you can recognize what are your perfect cubes, because 8 is 2 cubed and 27 is 3 cubed. submit their homework to the front. It will open up to this. Wait for it to load a little. Scroll down. There's this button at the bottom right hand corner for you to open it up bigger. So go on to full screen. Okay, are we all there? You all at this page already? Okay, I just have a very, very simple task for you. I just wanted to break the monotony because I know our lessons this semester are all in the afternoon. Okay, so I just want you to scroll this bar. Okay, this bar is to represent the value of A, which is the base number of the logarithm. Okay, what you have over here is the function x, y, as in the function being drawn, okay, on the axis x and y. You can scroll in, scroll out by just inching your scroll pad, okay, or just do your number finger thing, right? Zoom in and zoom out. Okay, can you help me to observe, right? What do you see about the shape? Okay, how is it that the shape changes? Right? Is there a particular condition that creates a particular shape? Right? I just give you maybe 30 seconds to explore this. Okay, before I call a name to give me an observation. I'll just write. So it doesn't pass through the y-axis. So we have to be very careful when we are going to sketch our graph. It needs to look like it is approaching the axis, okay, the y-axis, but it never touches it. Okay? So if I were to go back to my original size, here, okay, can you tell me under what conditions I get this shape? As you scroll through the bar, okay, what kind of numbers do you see about A such that you get this L shape looking thing? A is less than 1. Do you agree? Okay. If I have A going more than 1 itself, you notice that it totally changes shape already. Okay. So notice that it only happens when A is less than 1. Okay. But A must be more than 0. Because we have agreed that A must be more than 0 in order for a logarithm to be defined. So the condition about this is that A is more than A is more than 0 but less than 1. Okay? Then for the other case, although I limit your scroll bar all the way to 5 only, okay, but it doesn't matter, it still goes on forever. Okay? We notice that in order to get the other shape, it happens only when A is more than 1. Now, what else do you observe about the two graphs that happens for both graphs? For both shapes. Is there anything that is the same that happens for both?
What happens at 1?
What happens at 1? Which one are you referring to?
Sorry.
Okay, notice that as you scroll through the bar, in both cases, there is like a hinge point or pivot that doesn't change. You notice that it always hinges at this x-intercept or value of 1. Okay, so it never gets away from 1 at all. Let's think about it. Why is that so? Why must this be 1? Okay, if you think about it algebraically, my other color markers, we are looking at the function y equals to log x base A. Okay, regardless of any value of A, your x-intercept itself, it is referring to when y is equals to 0. Right? X-intercept, in order to look for it, your y is equals to 0. So what happens when y is equals to 0 when you want to solve this? We get log x base A to be equals to 0. Right? And if I were to change this into my index form, I will get A to the power 0 equals to x. And we know that anything to the power 0 is 1. So that's the reason why your x is equals to 1. Understand? Okay, so it's a very logical reason over why the x-intercept is 1. Okay? But of course, I do not want us to always think that whenever you draw any logarithmic function, okay, the x-intercept must always be 1. We rely on the basis of x-intercept being when y equals to 0. Okay? Because could it be a case, when will there be a case whereby x is not equals to 1? Or rather the x-intercept is not 1?
Plus something behind.
There might be something behind the function. Okay? Your expression of the function might be different. Right? So maybe 3x. Maybe 3x plus 1. Okay, let's consider. Okay, how will the graph of this actually look like? Right? So if I were to consider y is equals to 0, and I try to solve this, I will get a to the power 0 equals to 3x plus 1. A to the power 0 is 1. And then I solve and I find that x is actually equals to 0. So don't memorize that logarithm graph, your x-intercept must be 1. So it still depends on your expression itself. So in this particular example, I gave you 3x plus 1, and I find that my x-intercept is actually equals to 0. So what does this mean? If my A were to be maybe 2, okay, that means my graph shape will be this way. But it passes through x equals to 0, so in fact it passes through the origin. So my graph will look something like that. Okay, the asymptote will actually be, instead of your y-axis, it will be x equals to -1. Okay, but that's a little bit beyond us for now. Okay? Questions? Right? So you'll be expected to learn how to draw, or rather to sketch, okay, the logarithmic function itself. Right? So this is what I wanted to bring you through to help you understand the graph shapes. Okay, you can keep away your notebook already. Is that if I were to look at the ln function, meaning to say your y equals to ln x. For y equals to ln x, can you tell me what shape should we actually take? What shape should we take? The first one or the second one? Second one, why? Because ln is your natural log. It has a base of e. Okay, and if you were to key in your calculator for the value of e, it is 2 point something. Okay, you can go and check. I hope I got it correct. It's 2 point something. It's 2.718. Okay, so because of that, that means that your base is more than 1, so it should be getting this shape. Okay. The unique thing about your natural log function is that it is actually an inverse function of your exponential function. So if you recall back in, I think, chapter 5.2, we did look at graphs of exponential function. In fact, in Emacs, we also look at exponential function. So y equals to e to the power of x, okay, it will intersect at y to be equals to 1, right? Because when x is 0, e to the power of 0 is 1. Okay? So your y equals to e to the power of x and y equals to ln x is actually a reflection of each other. Reflection where? How does it reflect? It reflects along the line y equals to x. Okay? And that's because they are inverse functions of each other. Just like maybe you can think of your sine and sine inverse. Okay? Yeah. Okay. I'll skip try 25 because we'll just rejoin this thing. So I want us to look at the applications part. In your textbook, try 26. Logarithmic function is very often used in many different applications. I am not sure whether, I don't think in physics at secondary school, you will have to draw any graphs using logarithmic function. But if you were to pursue it at JC, definitely when you do your practical exam, it is expected of you to know the logarithmic function and then do your physics experiment. Okay. In chemistry itself, you also need to be familiar with the logarithmic function because that's often used in your pH value related to that. Okay. Then, if you want to pursue geography, where you're looking at your earthquakes and all that, that's also a Richter scale. Okay, that is a measure of the intensity of the earthquake. That is when logarithmic functions are also being used to model. Okay, so don't tell me that learn all these no use. Okay, maybe you're not going to be a physician, chemist or geographer. Okay, but all these things are still useful in real life. Okay. So we look at a chemistry example. So they say that pH is a measure of the acidity of a solution. I hope you are familiar with acid and bases already. So we have this formula given to us, where the pH is being calculated by negative log base 10, and then they intentionally put this square brackets with a H plus. That is your concentration of your hydrogen ion. That is how they define it. Okay, so it is being measured in moles per liter. I don't think you all have done mole calculations yet. Right? Oh, just started. So you all know what's a mole. You don't need to ask me, I cover everything. Okay. Although that is my best topic in chemistry already. Right? So in part 1, okay, the pH of human blood is normally about 7.4. Okay, what is the hydrogen ion concentration? So they gave you the pH value, which is 7.4. They want you to find out the concentration of the hydrogen ion. So how to go about solving this? Bring the negative over first. It will just be your usual solving of a logarithmic equation. So we're trying to find out what is your concentration of hydrogen ion. Okay. That will be equals to 10 to the power negative 7.4. Right? Then we press it into a calculator because the question wants it to be in scientific notation. Is it scientific notation? Oh, okay. So that means that they don't want it to be in this manner. I think they need standard notation, not scientific notation. Yeah. Okay. I think your textbook might have written it wrongly. I don't know what is a scientific notation actually. I think they meant some standard notation. Then now comes the question, do you know what is standard notation from your test? Okay. So 3.98 times 10 to the power negative 8. Must have the times 10. I don't know why your people in class test standard notation don't have times 10. pH equals to? The question gave it to you, what the formula? Yeah. Did they tell you that? Page 127, what? Did he not tell you? Oh. I think because they carried forward from example 26. Yeah. Example 26 on page 126. They were using that context. Yeah. Next one, see. Okay. You don't have to memorize this formula, it will be given to you. Depending on the context itself. Right? Next we look at part 2. The question says a solution with pH less than 7 is called an acid, and a solution with pH greater than 7 is called a base. I believe you know that already. Right? Wait. Okay. Yang Yi, I don't know why you're smiling at your homework. Okay. Black coffee has a hydrogen ion concentration of 5.1 times 10 to the power negative 5 mole per liter. What is the pH level? Is black coffee an acid or a base solution? Okay, so we will just have to let your hydrogen ion concentration to be 5.1 times 10 to the power of negative 5 to calculate the pH. Will you key this into your calculator and check whether you are able to get a value that is the same as your friend and also mine. I want you to key in the calculator first. What do we get? Zero, what do we get? You can dream of the lucky numbers. Let's calculate it. Okay. 4.2924. Okay, so is it acid or a base? It's an acid, huh? Okay, so black coffee is acidic. Erase this. Next, part 3. If black coffee in part 2 is diluted by a factor of 15, how would its pH be affected? Okay, so I want to explain what does the question mean by diluted by a factor of 15. Okay, so that means your concentration of the hydrogen ion is being diluted. So in the idea of dilution, okay, can you think of what operation will be suitable for the idea of dilution by a factor of 15?
Neutralize.
I'm talking about operation, like plus, minus, times, divide. Division, right? Okay. So you need to make a natural a guess, okay? Because there might be times whereby you read terms that you don't understand. So why is it division and why not subtraction? Okay? Because the question says by a factor. So when you think about factors, they are all in multiplication, right? So therefore, since we're diluting by a factor of 15, we are taking the original concentration to divide by 15. So we take the original hydrogen ion concentration to divide by 15. That is what it means by dilution of a factor of 15. Yes, Isaac. Okay. Hence, we will get a value of. Can you press calculator now? Press this in the calculator. Tell me what's the answer. What do you get? 5.4685. Okay? That is your truncated 5SF. Final answer 3SF, 5.47. Okay? Question is also asking how would its pH be affected? Okay, although technically I would have phrased the question better. So when they ask how would its pH be affected, they're actually asking what is the difference in the pH levels. Okay, you will get 5.4685 minus away 4.9. Okay, and we get about 1.1764. Bear in mind that we should have our truncated, our intermediate working to be in truncated 5SF instead of using 3SF values. Okay, for accuracy. Okay. I can sense that you're getting a little bit bored and you actually don't need me to explain so much. I want you to try 27, do try 27, and also exercise 5.5 question 6. And maybe try question 30 also. Okay? But I want us to just focus on these two first. Okay, can you do that now? Give you about 10 minutes to work on the two questions, the main one. Are we done? Can I run through the answers? Okay, I hope you're able to get 27 part I. Try 27 part I's answer. Any issues in doing that? Okay. In part 2, question says find the time when temperature is equals to 50 degrees Celsius. So I hope that at the very minimum, we're all able to substitute in big T to be equals to 50. Okay, we want to find a small value of T, that is where it depends on our algebraic manipulation skills. Okay, small T is over here in the power. We need to bring everything else that's furthest away to the other side of the equation first to balance. So we first minus away 27, get 58 times 0.92 to the power of T. Okay, and that will give us 23. Then we can divide 58 over to the left hand side. That will give us 0.92 to the power of T. I do not recommend that you go and calculate for decimal first. Okay, just keep everything exact as far as we can. Right? Then from this, how do we bring the T down to make it the subject? Okay, we have to do our logarithms. So you can log both sides. Apply our common log. And that will help you bring the power, the T power down to the same level. Okay, so we will then have T to be equals to log 23 over 58 divided by log 0.92. I skip a little bit of steps over here, but I hope you understand. What I just did was just bring the T down. That is T times log 0.92 already, so that we can divide it here. Then we can key this into our calculator, so that we can get a more precise answer, and that will give us about 11.092. Okay, for which we have 11.1 when rounded to 3SF. Okay. Then in part 3, we want to show this. Small t is equals to log base 0.92, then t minus 27 over 58. Actually, this is not a challenge if you understand what we're doing over here. Okay, just that over here in part 2, we have numbers put in already. But over here, we're just doing it with the unknowns small t and big T. So the process is the same. We bring 27 over to the left. Then we divide by 58. Then we log on both sides. Okay. Oh wait. down here is log 0.92. Actually, I mean, it doesn't matter, we can do this. Just say the power t comes down. Okay, eventually I will need to divide log 0.92 over to the left. So t is equals to log t minus 27 over 58 divided by log 0.92. And remember, I will change our base. Okay, whereby if I will change our base to base 10, then we will split it out into this way. Essentially what this means is a base of 0.92 t minus 27 over 58. Right? So instead of thinking of it in this, sorry, this one is LG, not LG. Okay? We tend to think from here to here by changing our base to base 10. Right? But then actually, we can think about it in reverse as well. So the denominator's number is our base, and then the numerator's number is actually over here. Right? So that's how we show it. Okay. Next, we look at question 6. We're looking at radium. It's a radioactive material. Okay, so it takes the symbol Ra and then 226. So the question says that at the beginning, your radium has 100 grams to it. Part 1 asks how much radium would remain after 10,000 years. So you just substitute in T to be 10,000 and you'll be able to get the value of 1.39. In part 2, the question is asking how long will it take before the amount of radium is halved. So since you're looking at half the amount of radium from the beginning, so your R value will be 100 divided by 2. That will be 50 grams. So we substitute in this value into your formula. Be very careful about the number of zeros. So we get this. And then we simplify it. So e to the power of all that is equals to 50 over 100. So we get half. Okay, and then you can do your log on both sides, or else it's just a change to log form. So you will get half equals to negative 0.004279. And then t will be calculated by taking log half divided by negative 0.004279. Okay. So we get about 1619.88. Okay, the question was asking for the number of years. Okay, how long will it take before? Oh, sorry. The question is asking for it for t to be number of years, but we are just rounding off to 3 as in this case. Okay. Right. Tomorrow I'm not seeing you. Why? Any idea? Yes. Okay. So tomorrow I don't get to see you because of the mother tongue listening for free. Okay. So I'll see you on Wednesday. I'll see you on Thursday instead.